All right, let's look today at another method of solving linear equations. Graphing is great, and we know that when we have two lines that cross, their solution is where they cross. But it is really, really, really not always convenient to solve things by graphing. Sometimes the graphs don't line up on perfect whole numbers, and sometimes graphing is just a pain. So I'm going to look at this equation. 3x, oh, hi. That is way bigger than I wanted it to be. So we have 3x plus 6y equals 12. So the rules of math say I can do anything I want to this equation. I can, if I want to, I can add 5 to both sides of this equation. I don't know why I would want to, but I can. That's mathematically legal. Or I could multiply both sides of this equation by 4, right? And then I'd have to multiply the other side of the equation by 4. As long as I do it to both sides, I can do whatever I want to whatever equation I want. So I'm going to use that because I have two variables in each of these equations. But I'm going to use this property that I can add the same thing to both sides of the equation to be able to get rid of a variable. So let's see what happens. I'm going to add 2 to both sides of this equation right here. But I'm going to do it in different ways. 4x minus 6y equals 2. So I'm going to add 2 to this side of the equation, but I'm going to add 4x minus 6y to this side of the equation. I'm adding 2 to both sides of the equation because I know that 4x minus 6y equals 2, so it's completely legal, but I'm doing it in different forms. So 12 plus 2 is 14. 6y minus 6y is 0, and that term actually completely goes away. And then we have 3x plus 4x equals 7x. So what I did is by adding these two equations together, adding 2 to this side in this form and adding 2 to this side in this form, I have eliminated a variable, okay? So now I have 7x equals 14. I know how to solve that. I divide both sides by 7 and I get that x equals 2. And then I know that if I want to know, okay, what does y equal when x equals 2? I just pick an equation. I'm going to use this one because it's there. 3 times 2 plus 6y equals 12. So I end up with 6 plus 6y equals 12. I know how to solve a two-step equation. I'm going to start by subtracting 6 from both sides. And I end up with 6y equals 6. Divide both sides by 6 to eliminate that and get the y alone. And y equals 1. So my solution is the point 2, 1. It's not always a bad idea to just go x, y, so that you remember which one's first. And then I circle this. This is all great, but this is what I want for an answer. And I solved these systems of equations because I added them and I eliminated a variable. So this is great because there was a 6 and there was a -6 and we added them and it went away. But they're not always like that. It doesn't always work out that it magically disappears. So I look at this and I have to say to myself, is there anything I can multiply one of these equations by so that it'll work? So if I multiply this equation by -8 and add it to this equation, those x's will be eliminated. If I multiply this equation by +2, these y's will be eliminated. Or I could divide this equation by -8, and those x's will be eliminated. Or I could divide this equation by 2, and the y's will be eliminated. I'm going to go ahead and multiply both equations by 2, and I'm going to eliminate the y's. But it doesn't matter if you eliminate the x's. It doesn't matter if you eliminate the y's. So 2 times x is 2x. 2 times y is 2y, so plus 2y equals 2 times 10 is 20. So now I'm going to add these equations together. So I have 16 plus 20 is 36. I have negative 2i, positive 2i. Those are 0, and they go away, and I'm not even going to write them down. And then I have 8x plus 2x is 10x. So I have 10x equals 36. So now I want to isolate that variable, get the x alone. So x equals 3.6. Oh, this is one. It's not a beautiful whole number. So if I had graphed these, it would have landed on 2, 1, and it would have been easy. But this, try figuring out that it's landing on 3.6. That one's not easy. So I'm going to go back to my original equation, x plus y equals 10, and I'm going to substitute in 3.6. So 3.6 for x plus y equals 10. I could have substituted in this top equation, but that would have been a few more steps. So I didn't. So I'm going to subtract 3.6 from both sides so I can figure out what y equals. And y equals, let's see, 10 minus 3 is 7, minus 0.6 is 6.4. So my solution is the point 3.6, comma 6.4. So not pretty numbers, but that's okay. We can deal with numbers that aren't pretty, and that's my answer. So some of these, like we have a 5x and a negative 5x, they will eliminate really pretty easily. And some of these you might have to do some multiplying, like the 3 and the 2 and the 9 and the 7. You might need to multiply. Let's see, you can either multiply the 2 times 3.5 to cancel out that 7, or you can multiply the 3 times negative 3 to multiply the 9. Just remember, whatever you multiply to one side, you need to do it to the other. But it's pretty straightforward stuff. It's a great way to solve systems of equations if you don't want to graph. Bye.